Write the equation of a line passing through the point 2, negative 3, perpendicular to the line y equals 2/5 x plus 1. If you'd like to work the example first before seeing the solution, go ahead and hit pause and then check your solution. First thing, if I want to be able to write the equation of a line, I need two pieces. I need a point and I need a slope. I do have a point, and that's given to us in the problem. We also need a slope. Now this one, a little bit more work involved. I want perpendicular to the slope. Given slope is 2/5. The equation of the line is in slope-intercept form, and we can pick out the slope rather easily. If that's the slope of the line, the perpendicular slope is the opposite reciprocal. Opposite meaning I'm going to change the sign. So if it's 2/5, my perpendicular slope will be negative. And the reciprocal of 2/5 will be 5/2. So now we have our point and we have our slope. Let's go write the equation. We'll start in point-slope formula, where we've got y minus the y value is equal to the slope. Now be careful, we got a couple slopes floating around here. I wanted the perpendicular slope, and so that's the negative 5/2 times x minus the x value. So now we're in point-slope formula. Here's our first. Let's go ahead and change it to the other forms. I want to go to slope-intercept. What I don't want is that parentheses, and so we can clean that up. Oh, I forgot to mention, in that point-slope formula, we could have cleaned it up just slightly. I passed by me here. Y minus a negative 3, we could rewrite that as y plus 3 is equal to negative 5/2 times x minus 2. All right, let's go ahead with that one. I do not want that parentheses. So we'll take that negative 5/2 that's on the outside and we'll do a distribution. We'll take negative 5/2 and multiply it inside that parentheses. So I get y plus 3 is equal to negative 5/2 times x will be negative 5/2 x, and negative 5/2 times 2, negative times a negative will be positive, and 5/2 times 2. Now we will clean that up just a bit. We can simplify. We can make that 2 a 2 over 1 if that helps. So we get y plus 3 is equal to negative 5/2 x plus 5/2 over 2, or excuse me, 5/2 times 2 becomes 10/2, or just 5. Almost in slope-intercept form, we want the y isolated all by itself. What I don't want is that 3. And so in order to not have that 3 there, I'd like to zero it out. And so putting a negative 3 on both sides, adding a negative 3 to both sides. Negative 3 and positive 3, that's going to combine to be 0, so I'm left with a y on the left-hand side. Negative 5/2 x, positive 5, and negative 3 will become a positive 2. And there's our slope-intercept. One more form. If we change this to standard form, I would like to have the x and the y on the same side. So the y is fine. That negative 5/2 x, I would like to have that not on the right-hand side. Let's move it to the left-hand side. Since I don't want it on the right-hand side anymore, we're going to zero it out. So we'll add 5/2 x to both sides of the equation. Adding the same thing to both sides keeps it balanced. On the left-hand side, nothing combines. So 5/2 x plus y is equal to 2. Now we're just about in standard form. In standard form, we would prefer to have the x term positive, which it is, but I would also like no fractions. In this case, 5/2, in order to make that not be a fraction, we can multiply by the least common denominator on both sides. So 5/2 x plus y equals 2 we're going to multiply both sides of that equation by the least common denominator. In this case, applying the same thing on both sides keeps it balanced. So if I take 2 times 5 halves x, we'd end up with 5x. 2 times y will become 2y. 2 times 2 is 4, and we are in standard form.